Hello, good evening, friend. Today I'm going to explain the aldehyde, ketones, and carboxylic acid. In this chapter, we are going to discuss the method of preparation and chemical properties. We are not going to discuss in detail, but in short, in so very short, we will discuss what are the reaction and how they proceed. So first one, we are going for the preparation of aldehyde, then we will move for the preparation of ketone, and finally we will move for the preparation of carboxylic acid. So let us see what are the preparation of the aldehydes. What are the methods from the aldehyde? Now the easiest method is from the alcohols. Okay, the easiest method to prepare the aldehyde is from the alcohols. What you do, you need to take the PCC, because alcohols directly, if you are taking the strong oxidizing agent, they will directly convert into the carboxylic acid. So what we are doing, we are specific, we are taking the PCC catalyst. It will restrict the oxidation up to the aldehyde. So first method is the from the oxidation of alcohol by the PCC. Now the second method is by the dehydrogenation of alcohol. Now dehydrogenation means removal of the hydrogen molecule. So what we are doing here, you are taking the primary, secondary, alcohol, and then we are passing through the copper powder, okay, heated copper powder at 573 Kelvin. So what we are going to get, that is the hydrogen gas is getting out and what alcohol is getting formed. Okay, now let us move for the another method, that is ozonolysis. Ozonolysis, when you are go to ozonolysis, in the ozonolysis what we are taking, that is the alkene. Generally we are taking the unsymmetrical alkene. So if you are taking the unsymmetrical alkene, it will form the ozonide. Firstly it will form the ozonide. This ozonide again reduced this ozonide again reduced and form the aldehyde. Okay, and now your next reaction is the Rosen-Moon reduction. This is also very important named reaction, Rosen-Moon reduction, where there is a palladized barium sulfate we take, and in the presence of dihydrogen, it will reduce the that is the benzoyl chloride. It will reduce into benzaldehyde. Now the next one is the Stephen reaction, very important reaction, that is Stephen reaction. For the board point of view, they ask the name reaction and student get confused what are the reagent. So in the Stephen reaction, that is the reagent we use, that is stannous chloride and hydrochloric acid. So alkyl nitrile, nitriles are getting treated with the stannous chloride. So this they give the intermediate, which on the hydrolysis gave the aldehydes. Now the next method is from the nitriles only, but by use of the DIBALH, means diisobutyl aluminum hydride. So let us see the other method. So if you are taking the RCN, okay, and you are taking the diisobutyl aluminum hydride, so it is the RCN directly converted into RCHO. So alkyl nitrile, to prepare the aldehyde from the aldehyde from the alkyl nitriles, either you use the Stephen reaction, or you can use the diisobutyl aluminum hydride. So it will give the aldehyde. Now again, if you see, that is the aluminum hydride, diisobutyl aluminum hydride, do not interfere with the double bond. Okay, so only it reduce the CN group to CHO, oxidized CN group to CHO. Now let us move for the another. If you are taking, that is the little long ester. Okay, so ester can also be oxidized to aldehyde by the use of the diisobutyl aluminum hydride. So next one method is there by use of the chromyl chloride. This is the important reaction, that is known as also the Itard reaction, where you are taking the toluene and you are heating with the chromyl chloride in the copper CS2 solution. So it is giving the intermediate, which on hydrolysis is giving the benzaldehyde. So this method are there, that ester or alkyl nitrile, okay, can be reduced easily by the diisobutyl aluminum hydride, and with the help of chromyl chloride also we can reduce the oxidize the toluene to the benzaldehyde. Now let us move for the another problem, and the problem next problem is next method is by the action of by the action of chromic oxide and anhydride on toluene. Okay, so chromic oxide chromium oxide is there, CrO3, chromium oxide, that is what, CrO3, and plus anhydride is there. So what you are doing, you are taking the toluene and you are heating at 273 to 283 Kelvin by Cr2O3, and acetic anhydride is there. So they are giving the intermediate compound which on hydrolysis is decomposed into the benzaldehyde. Now next method is there by side chain chlorination followed by the hydrolysis. So what in this method, what you are doing, you are taking the toluene and in the presence of UV light you are heating with the chlorine, so it will give the intermediate, with an hydrolysis give the benzaldehyde. Now the Gartermann-Koch reaction, see, you try to you will be able to confuse with this reaction, because Gartermann reaction is also there in the aniline chapter, and where that is the you are preparing the the haloarenes, like that is the haloarenes you are preparing. But here Gartermann-Koch reaction we are preparing the benzaldehyde. So how you are preparing the benzaldehyde? Take the benzene and heat with this benzene with the carbon monoxide and HCl in presence of anhydrous AlCl3. It will directly give the benzaldehyde. Now let us move for the another method of preparation of the aldehyde ketones. Now the preparation of aldehyde is over. Now we are moving for the preparation of ketone. There are so many methods which we already studied can be used for the preparation of ketone, like the dehydrogenation of the secondary alcohol will give the ketones, and from the ozonolysis also we can prepare the ketones. Now what we are moving for the preparation of ketone from the acyl chloride. So if acyl chloride can be heated with the dialkyl cadmium, if you are heating that two molecule of acyl chloride with the dialkyl cadmium, it will give the ketones, okay, and cadmium chloride, this will give the ketones. Now when you are moving to the from the nitriles and Grignard reagent, that is the Grignard reagent is attacking on the carbon of the alkyl nitriles, and it is giving the intermediate, and which on hydrolysis it is again giving the ketones. And next last one is the Friedel-Crafts acylation reaction. When acetophenone is treated with the benzene in the presence of anhydrous AlCl3, it will give the acetophenone, that is the ketone. Now let us move for the chemical properties of the carbonyl compound, that is aldehyde and ketones. So generally the chemical properties are common from the aldehyde and ketones, but the ketones are less reactive, nucleophilically less reactive compared to the aldehyde. So what we are going to study? Firstly we are going to study the nucleophilic addition reaction, oxidation and reduction reaction. Nucleophilic addition reaction are having the numerous example. Few example we are going to study. Firstly, addition of nucleophilic addition of HCN. So what is the HCN? If you are ionizing HCN, it will give the Cn minus ion and H plus ion. So Cn minus ion, what it will do? It will attack on the carbonyl carbon, electropositive position, and they which result in the formation of intermediate, which on absorption of proton, it will give the cyanohydrine. In cyanohydrine, what is there? That is OH group and CN group both are there. So that is the name is cyanohydrine. Now next one is addition of sodium hydrogen sulfide. Okay, sodium hydrogen sulfide. So when you are going to add the sodium hydrogen sulfide, you treat the ketone or aldehyde with the sodium hydrogen sulfide. It will give the it will give the product containing the SO3Na plus OH group. Now next one is the addition of Grignard reagent. If you are heating the carbonyl compound with the Grignard reagent, it always give the alcohols. Similarly, you prepare the alcohols. Okay, this is the reverse reaction actually. Preparation of alcohols also has been done in the previous chapter. So similarly, if you are heating the Grignard reagent with the carbonyl compound, it will give the alcohol. So acetaldehyde will give the ethyl alcohol, and while the other aldehyde, it will give the ketones. Now next one is the addition of monohydric alcohol. Okay, monohydric alcohol means single OH group. So if you are going to aldehyde, you are treating with the ROH, it will give the intermediate, which again react with the ROH, it will give the acetal. In acetal there is two OR group is there. Okay, now let us move for the another chemical properties. And what are the other chemical properties? Addition of the ethylene glycol, dihydric alcohol. So in dihydric alcohol, how the reaction will be taken? Oxygen of the carbonyl compound and the two hydrogen of the ethylene glycol will be taken out, and it will release in the form of the water, and remaining with the intermediate what the compound will form, that is the ethylene glycol, ethylene glycol kettle. So that is also known as the kettle. Okay, this is the cyclic compound that is known as kettle. Now addition of ammonia and its derivative. So ammonia is derivatives, how the derivatives is formed by the replacing of the hydrogen. Okay, so if you are replacing the one hydrogen by the Z atom, so it will give the NH2Z and H2O. Now the Z group can be anything. Z group can be OH group, or it can be the R group, anything, or it can be the phenyl group. Anything group is possible with the Z. So these are the Z value. Now the ketone is there. When you are treating with the ZNH2, it will give the intermediate, and again it will give the final product by loss of water molecule. So now let us move for the example. Firstly, we are adding the ammonia. So if you are adding the ammonia with the carbonyl compound, what will happen? It will give the imine. Okay, imine. If you are heating the ammonia with the help of the if you are heating the ammonia with carbonyl compound, imine will form. Why imine will form? Because the number of hydrogen is less. Now let us move for the another problem. If you go for the another problem, so what the other problem is there? If you are heating with the alkyl amine, okay, that is alkyl amine means primary amine, so it will also give the Cf base, that is substituted amine. Okay, imine. Now next one is the hydroxylamine. So if you are heating the carbonyl compound with the hydroxylamine, it will give the oxime. Now lastly, if you are heating the a carbonyl compound with hydrogen, it will give the hydrazone. The reaction is very easy. That is, you are just all the cases we are removing the water molecule only. If you are taking the carbonyl compound and heating with the phenyl hydrogen, it will give the phenyl hydrazone. Why this gene is converting into zone? Because there is the decrease in the number of hydrogen atom. Now if you are taking the carbonyl compound and treating with the 2,4-dinitrophenyl hydrogen, 2,4-dinitrophenyl hydrogen, then it will give, that is there will be the loss of water molecule like that, oxygen of carbonyl compound and hydrogen from the hydrogen will be gone out, so it will give the product by the loss of the water molecule, and the name will be 2,4-dinitrophenyl hydrazone. Okay, now let us move for the another chemical properties of the carbonyl compound, and to see what are the other properties. Action of the semi-carbazide. This is a very, very important reaction, because this reaction is asked in the board exam, because here the student get confused that how many nitrogen atoms are there. Okay, in the semi-carbazide there are 3 nitrogen atoms are there. Okay, semi-carbazide is the amide, this is the amide. So amide is attached with the hydrogen, so that becomes the semi-carbazide. In semi-carbazide, that is combined with the carbonyl compound, and there will be the loss of water molecule, and it will give the semi-carbazone. Now reduction reaction. Now the reduction reaction is 2 types of reduction reaction there: direct reduction to the hydrocarbon and reaction into alcohol. So when you are doing the reduction with the lithium aluminum hydride, it will give the alcohol. But when you are going for the name reaction like the Clemmensen reduction and Wolff-Kishner reduction, and Wolff-Kishner reduction is when you are taking the Wolff-Kishner reaction, will take the hydrogen. Okay, so when you are treating the hydrogen with the carbonyl compound, it directly gives the hydrocarbon. And if you are taking, in the case of Clemmensen reduction, when you are taking carbonyl compound and treating with the zinc amalgam, it will also give the alkane, that is hydrocarbon. Now let us move for the another property, that is the oxidation. When you are moving for the oxidation, oxidation is also just 2 types, just like the reduction. Okay, so two types when you are taking the mild oxidizing agent, and that is another is the strong oxidizing agent. So ketone is easily get oxidized. Okay, so if you are taking the strong oxidizing agent like the nitric acid or potassium permanate or the dipotassium dichromate, this will all this will easily give the carboxylic acid. Even if you are having the ketone, it will also vigorous oxidation, it will give also carboxylic acid, depending on the cleavage of the ketones, the product will be decided. Now the when you are taking the mild oxidizing agent, so there are the three reactions are there: Tollens test, Fehling test, and haloform test. So in the Tollens test, what you are doing, you are taking the freshly prepared ammonium nitrate, basic medium. So it will give the silver mirror. Okay, so there will be the formation of silver mirror, that is saying that is the given aldehyde is given carbonyl compound is aldehyde. This test is not given by ketone. Now the when you are going for the Fehling test, you are taking the Fehling solution A and Fehling solution B. It again it will give that is the cupric oxide. This cupric oxide is the red bound property. So when you are treating this in the Fehling test, you are taking in the one sample you are taking aldehyde and another sample you are taking ketone. So the sample which is containing the aldehyde, if you are taking the Fehling solution A and Fehling solution B, it will give the red bound property. And if the sample has given the red brown precipitate, it means the given compound is the aldehyde, and the compound which is not able to give the red brown PPT, it will be the ketones. Now let us move for the next important properties, that is the oxidation of methyl ketone by haloform reaction. This is very confusing and very important reaction, because this reaction is given by the compound is having the methyl ketone group. Okay, methyl ketone group and what methyl hydroxyl group. Okay, so if this group is there, methyl ketone or methyl hydroxyl group, the compound will give the haloform test. Okay, so this haloform test, when you are treating the carbonyl compound with the sodium hypohalide, when you are treating the carbonyl compound with the sodium hypohalide, it will give the sodium salt of carboxylic acid and haloform, that is the iodoform it will give. So what the compound will give this iodoform test? Those who are having that is methyl ketone group or that is the methyl hydroxyl group. Now let us move for the another type of properties, that is the reaction due to the alpha hydrogen. Okay, reaction due to alpha hydrogen, it gives the aldol condensation. Okay, aldol condensation and cross aldol condensation. What you are doing, that is the carbonyl compound, whether the aldehyde or ketone having the alpha hydrogen, they will undergo the condensation reaction with the in the presence of base and form the beta hydroxy aldehyde or beta hydroxy ketone, which is quite unstable. On little the elevation in the temperature will give the alkenes, alkenes with the aldehyde or the carbonyl compound. So here if you are taking the 2 moles of acetaldehyde, you are treating with the sodium hydroxide, it will give the 3-hydroxybutanol. 3-hydroxybutanol also can be write that is beta hydroxybutanol, and on the loss of water molecule it will give but2-enol. Now you take that is ketone also, they are having the they are having the alpha hydrogen, so this will also undergo the aldol condensation in the presence of base and they will give the condensation product. Now let us move for the another type of the reaction, that is cross aldol condensation. Cross aldol condensation means that is the different type of the carbonyl compound we are taking having the alpha hydrogen. So suppose you are taking the acetaldehyde and the ethanol and propanol. So there are two cases, because in the sample you are having the ethanol propanol. So what the condition are there? 3 cases are getting formed. Either the 2 ethanol is combined, or 2 propanol is combined, or 1 ethanol and 1 propanol is combined. Suppose 2 ethanol is combined, it will give the beta hydroxyaldehyde, and if there is a 2 propanol is combined, it will give the 2 methyl pen 2 enol. And if one ethyl, one ethanol and one propanol will combine. So it is also that which one is the first compound you are taking, that also determine the type of product. So first product will be there 2-methyl butenol and pent 2-enol. This is the product of the aldol condensation. Okay, that is cross aldol condensation. Now we'll move on the another type of properties. Let us see the what are the, that is the, here the we are taking the aromatic aldehyde or aromatic ketones. They are also undergoing the aldol condensation. In this what we are having, that is the one we are doing acetophenol we have taken, and that is another is the benzaldehyde. This undergoes aldol condensation. They have given 2-methyl pent-2-enol. Okay, now Cannizzaro reaction. The aldehyde and ketones having no alpha hydrogen, they undergo the Cannizzaro reaction in the presence of base. They will give the one molecule of alcohol, and another is the sodium salt of carboxylic acid. Okay, so this is very simple reaction. Now let us move for the another properties. Another properties are what, that is the, this reaction is also having, that is the formaldehyde we have taken because there is no alpha hydrogen with the base. When you are heating, this will give the methanol, and that is formic sodium salt of formic acid. And if you are taking 2 molecule of benzaldehyde, it is also having no alpha hydrogen. So what it will give, this will give the phenyl alcohols, benzyl alcohol and sodium salt of benzoic acid. Now let us move for the another, that is electrophilic substitution reaction is also given by the this compound, that is the aromatic aldehyde. So what the reaction they are giving, the first reaction is nitration reaction, and we know that is the benzaldehyde is the aldehyde group, is meta directing group, so it will give the meta nitro benzaldehyde. Now let us move for the another properties, chemical properties of the we are going for the preparation of carboxylic acid. This is also a very important topic for the board exam point of view. So preparation of carboxylic acid, when you are going, that is we can prepare by numerous methods are there to prepare the carboxylic acid. First method is the primary alcohol. So primary alcohol, if you are oxidizing with the Bayer reagents or alkaline KMnO4, it will give the carboxylic acid. And if you are oxidizing with the chromium oxide CrO3 also, it will give the carboxylic acid. And if you are taking potassium dicarbonate, dichromate, the alcohol will again be converted into the carboxylic acid. And if you are taking the longer hydrocarbon alcohols, again it will get oxidized into the alcohols only. You are taking the chromic oxide with the little amount of the sulfuric acid. Now from the aldehyde, okay, so aldehydes are very easily able to convert into the carboxylic acid by with the help of any oxidizing agent you take, that will convert the aldehyde into the carboxylic acid. Now next method is there from the alkyl benzene. Alkyl benzene is the toluene. We are taking toluene. If you are heating the toluene with the potassium permanganate, so it will give the sodium salt of benzoic acid, which on hydrolysis it will give the benzoic acid. No matter that is the benzene is attached to having the methyl group, butyl group, propyl group, this will always be full chain will be the oxidized into the carboxylic acid. Now the next method is there from the nitriles. Nitriles also can be oxidized into the carboxylic acid by the use of the water. Okay, so alkyl nitriles are there that can be directly oxidized into the carboxylic acid with the use of. And then next one is there amides. Amides are also very rarely able to convert into carboxylic acid. So here is the aliphatic amides are there, which on reaction with the water, or that is the hydronium ion, it is giving the carboxylic acid. And here the benzamide is there, this is also giving the benzoic acid. Now let us move for the another method of preparation of the carboxylic acid. Next method is the from Grignard reagent and carbon dioxide. So Grignard reagent will attack as as like the nucleophilic substitution reaction, and it will give the intermediate, which on hydrolysis will give the carboxylic acid. And from the acyl halide, if you treat the acyl halide with the water molecule, they will give the carboxylic acid with the simple method. From anhydride, again anhydride is there, that these all the anhydrides on hydrolysis will give the carboxylic acid. Okay. Now the next method, when you go for the preparation from the ester again what will go the hydrolysis, it will give the alcohol and carboxylic acid. Now this is the reverse reaction of the esterification reaction. And next one is there, any of the ester if you are heating with the base also, it is giving the carboxylic acid. Now let us move for the chemical properties. The first property is the acidic nature. So carboxylic acid is the acidic in nature. Why it is acidic in nature? Because we know if you are treating with the sodium, it will give what it will give, that is it will release the hydrogen gas and form the salt. If you are heating with the base, it will give the salt and water. If you are heating with the bicarbonate, again it will give the salt and water. So as like the acid give release the hydrogen gas on reaction with the metal, and if on reaction with the bases it give the water. Similarly, it is also carboxylic acid is also releasing, that is why it is acidic in nature. Next one is formation of anhydride. When two molecules of the carboxylic acid are combined in the presence of pentoxide, phosphorus pentoxide catalyst, it will give the anhydride, acetic anhydride. Now esterification reaction, equimolar of the number of molecule of the carboxylic acid and ethyl alcohol you are taking in the presence of sulfuric acid, it will give the ester. Now reaction with the phosphorus halide, so phosphorus halide, that we know, that is they will all give the acyl chloride. So all type of phosphorus halide or the thionyl chloride, they will readily give the acyl chloride. Now let us move for the another problem, that is reaction with the ammonia. So when carboxylic acid is treated with the ammonia, it will give the ammonium ion, and which again on the loss of water molecule, it will give the acetamide, amide. And similarly the benzoic acid, their reaction with ammonia, it will give the benzamide. And when you are taking the dicarboxylic acid reaction with the ammonia, what will happen, it will give the ammonium ion, which will give the pathylamide. That pathylamide again lost the ammonia, it will give the pathylamide. Okay, now let us move for the another problem is reduction to alcohol. Okay, so carboxylic acid is there, when you are heating with the lithium aluminum hydrides or B2H6 or then it will reduce into the alcohols. Okay, now if you are going decarboxylic reaction decarboxylation, so sodium salt of carboxylic acid you take and treat with the soda lime, it will give the hydrocarbon. HBZ reaction, that is the HBZ reaction, when you are treating the carboxylic acid having the alpha hydrogen, that will be what replaced by the halogen, if you are treating the halogen with the presence of red phosphorus. Now let us move the next properties. Next problem is ring substitution reaction. When you are going for the ring substitution reaction, there are carboxylic acid give the two types of reaction, 2-3 types, that is nitration reaction. As we know, that is a carboxylic group is the meta directing group. So if you are taking the nitrating reagent, and then it will give, that is meta nitro benzoic acid. And if you are doing the halogenation with the presence of bromine in the presence bromine and catalyst FeVr3, so it will give the meta bromo benzoic acid. So these are all about the chemical properties and preparation of the aldehyde, ketones and carboxylic acid. Thank you so much for watching, friend.